So thank you very much. I'm Christophe Mouton. I'm working at the PLM project at EDF, especially the engineering division. And yeah, I agree, we have a lot of authors for this paper. Yeah. If you want to contribute, so it's something that I was very keen in the past, and I was very happy to succeed with our partners to do in this last month. So it's a new way of drawing, designing 3D mock-up for our power plant based on X-Freedom, and I hope that you will feel my enthusiasm. So the agenda is quite, it will be this one. So we will discuss nuclear PLM first. I will try to show you a video that could help to have the global understanding of what we intend with this plant lifecycle management system. The challenges that we want to address in terms of R&D. And I will present after that the different systems that we assemble to succeed to show the demo at the end. We will be not live, but video. So EDF, if you want to know more about our group, edf.com. It shows the English version, of course. It's in French at the beginning. But you will see that we are quite a large utility in Europe. And and in France, we are the national historical one. So, nuclear PLM. So, I will switch, because I like to live dangerously. I will switch to the video. Okay. And the mouse to go somewhere. Perhaps we will have some sound.
and operators. What do you say we unite our talents?
Thank you, Professor. It was a good revision. So, I hope that with this video you will feel what we put behind the terms of PLM from EDF. So, as we already mentioned, we have all these plenty of particularities when we build nuclear power plants. We have all these tons of concrete, pipes, cables, and a huge mass of documents and, of course, reference for components. So here you have a different way to represent the same components of concept behind a different point of view. You have the authorities point of view, you have the supplier point of view, you have the design point of view, and you have the EDF guy operating the stuff. We have this way to represent, to move from the real power plant to the virtual digitized power plant. And the idea is to cover, thanks to the life cycle, from the design, very early design phases, to the decommissioning. And of course, we have to have in mind that it will last at least 1 century. Something very interesting is the fact that it's a collaborative work. In fact, large construction building involves a lot of different businesses, suppliers, stakeholders, and I like these drawings because you understand quite nicely how the mock-up, in fact, could be the center of the collaboration. So, as I already said, EDF is mainly based in France. So, in France, you have 58 power plants running 58 each running reactor, and we have several, I will say, models of our nuclear power plant. So we need to take in charge all this variety. So the challenges, collaboration, of course, and something that is not specific to our sector. It's something that is quite common in architecture, engineering, construction projects. Is that very often data are duplicated, occupied, and the Cabinet Office in United Kingdom has evaluated that to 15 to 20% of each project. So it's a massive loss of energy and money. And something that could help a lot could be the interoperability of the data that are used in the different mockups, data sheets, and so on. Another point is to the perennity this time, understanding the data over a century. When you have to compare with the roadmaps of your favorite CAD software, you have a release each year. So, is it possible after 1 century to still understand your data in the same way that you were using that in the design phases? I would say that the right answer will be international, for consensus, open, and standard. So I think it's the right place. Another point is, at EDF you have people specialized with very high skills in CAD software, but it's not the case for every people at EDF. So it's quite sad not be able to get the right data to the right person. And visualizing the 3D mockups today still needs CAD software and infrastructure, very, very heavy, very expensive. And I think that it's a question of usability of the 3D mockups. And I will say, let's try the answer of Web 3D. So, what is feasible today? 3D modeling in a web browser is not, I will say, a dream. It's really something feasible today. Last year in San Sebastian at the Web 3D 2013, we have seen this nice paper from Tamats. And you have this kind of modeling software running in WebGL. The app is called WebGL Studio, and it was also the base paper. And I think it's something very promising for our domain. On the right, we have the Shapesmith portal, who helps you to create parametric 3D object. So. And I remember there that with my colleague Thomas Pavio from Arts et Métiers Paris Tech, we have written this poster last year in San Sebastian about 3D macro-parametric approach, trying to bring something new to describe how we design our power plant. So it's mainly, I will say, CSG-based primitives to assemble and to align. So, what I'm quite proud about our project is that it was the right time to assemble a lot of ideas and feasibility, as I already presented. And why? To show that now it's totally feasible to connect web apps to centralized engineering databases, and running that with some high web semantics rules to check the rules between the behaviors of components and using the right pipes with the right tank and this kind of engineering rules. And we have drawn this architecture, and I will say that we are quite happy to show you today that what we have done thanks to these first ideas. So here you have a sequence diagram of what we want to achieve. The user, in fact, will be able to connect to the portal, and he will access to his project. So he has to create a component, a geometry for a component, and the system will answer with opening a web app. So what we will present you as a component editor, and he will assemble the different geometry primitives to obtain something that could be used to, I would say, to reserve the space, the volumes in the mockup. So here it's a tank, and we have a complete workflow that will store in our proposal, the Macro-Parametric Approach domain-specific language, to store that in the engineering database, and be able after that to run here a tessellated system that will generate X3D stuff and provide to the engineering database X3D, I will say, representation of the component. So once we have done that, we can use this component into something more or less looking very, it's very similar to what we're using today. So we're using at EDF the software from Aveva called PDMS, Plant Design, for Plant Design. And here you have the use of the diagram, the sequence diagram of the use of the plant editor. And this plant editor in fact help you to access to the various catalogs of components, and the users will implement in this plant editor the components that he has to achieve to draw the pipes and a system. After that, as we have stored every information, every geometry in our centralized main database, we will be able to ask for visualization. And visualization, in fact, in the way that the user could navigate in the 3D Mocker. And that's here future work, how we will manage to ask to this PLM the data that the user wants to publish or to consult or to navigate into. So, experiments and first results. So, the final architecture of our demonstrator is quite, I will say, tricky, but yeah, it works. And we are quite happy to show you in the next video and certainly this afternoon during the showcase that it's really working live. And here you have the different parts of our stuff. So on the left you have what we use to represent in the engineering portal directly thanks to X3D, the X3D representation of our components. It is stored here in the PDM and delivered through the PDM frontend to the web server. So it's quite easy. It's a web page, so no problem here. Here you have the component editor, so it's a X3D based component editor, and we will present you a little in a few minutes how it works. But this drawing apps allows the user to assemble the different parts of the geometry that he wants to use to represent a component, and then we push that to a 3D proxy server, which will translate the MPA DSL description to a server to create the tessellation, so the final 3D representation. So it's based on Open Cascade, so it's I would say an open source French CAD kernel. So just a few words about our macro-parametric geometry description, something that we introduced last year in the poster with our colleague from RCMT Paris. It's yeah, it's still very close to the Python code that is running on Open Cascade. But yeah, our idea is to provide something very dedicated to our drawing needs and very, I will say, human readable. So what we trying to push behind that is the idea of perennity, the idea of durability, of how we have described our components. Then I will let Max present his contribution.
Thank you, Christoph. So, as Christoph already told you, we have this so-called component editor, which is based on X3D. And on the bottom left, you can see some images. Okay, there's some delay. But okay, so here you can see some primitives that I can use in this component editor to assemble my component. And so a component is a combination of primitives, and it allows CSG operations. So we cannot do that in X3D directly on the client side, even though there are some screen space techniques out there. So what we have to do is we have to assemble the component and store it on a 3D server. The 3D server will generate a tessellated version that includes all the CSG operations. So here we have positive and negative primitives, and the 3D server generates a tessellated version, and we can then use that tessellated version very efficiently in the plant editor, which you will see, and in order to assemble the whole plant. But then the component cannot be manipulated anymore, primitives, but that's perfectly fine. That's the usual workflow. So the storage format for this component will then also be the macro-parametric format, which Thomas just showed you on the previous slide. So a combination of commands that use this parametric primitives. And our contributions to X-Freedom, which we made during this project, include the plane and cylinder sensors. So we have this little arrows here that you see, for example, this translation gizmo. We have a similar gizmo for rotation, and you can see it during the showcase. And I think you have even seen the plane and cylinder sensors in action in the previous talk. Okay, so let's go to the video. Oh yeah, it's already running. Oh yeah. So in order to start, we first have to go to the web portal. So this is the web portal used by EDF for the planned lifecycle management project, and it's not only maintaining our particular 3D component data, but also various kinds of data. It's very complex, and we first have to navigate to the component we want to edit, or alternatively, we can create a new component. So we can also search for, and then we simply click the Edit in 3D button, and our component editor application will be launched. So let's go. Of course, we have standard operations like translation, rotation, and scaling via adjusting the parameters of the parametric primitives. So here you can see a speed run of creating a tank. So on the bottom right, you have the element properties that belong to this specific component. On the upper right, you can see the transformation properties, and there you can pick the gizmos in the center, upper center. And here we can see an alignment operation, which will also be shown later on in the plant editor. So I can make a stop then and see more detail. So this is Christoph on his tablet editing the component, just for to illustrate that it also works on mobile devices. It's all web technology with plugins. So and now, you might have seen that there are these small green arrows on some of the primitives, and those arrows show vectors that are directly connected to what we call reference points or snapping points. And if we want to place a component somewhere or a primitive somewhere, we can simply select another primitive and then select another reference point and select an alignment distance. And by using those vectors and points and this alignment distance, we can then simply snap the primitives together. Okay, so now our tank is ready for export, and when exporting, we can select a subset or all of the reference points we had used here with the primitives to be used later on in the plant editor to align the whole component to something else. And we will also see that. So we select the subset that makes sense for our use case. Then we export it, and it will appear in the portal. So here, you might be able to read it if you're in the front row. This is the macro-parametric description which is stored here. So it's not any tessellated version, it's really the macro-parametric description of the component. And what you see here is the same component, but already tessellated by the 3D server, so it's all happening in the background. So now we are in the plant editor, which looks pretty similar. And on the bottom left, we don't have primitives. We don't have the primitive catalog, but we have a component catalog now. And this is already the tessellated component. But it also has the reference point to export it. So we simply place it somewhere, then clone it here. We have a second tank. And then we select some elbow components, place them there, and select both of them by adding a pipe. You can of course group the whole thing and clone it again. In this way you can quickly create a spatial layout of your plant structure for planning. And another interesting aspect, which we will not cover during this talk, but you might already have seen some demos, is that we are working on a large model visualizer to see this whole plant mock-up, maybe even combine some of the mock-ups that engineers create and inspect it in real time using web technologies. This is a very large data set, and we are rendering it in X3D. And you can see that we can here place annotations to the review and inspect tickets and so on. So thanks a lot.
So a few screenshots of the presentation on the website. So it's the main steps that Mark's presentation. So conclusions and future work. So we are very happy from the EDF side to have this successful proof of concept. We are able, thanks to plugin free and thanks to the nice X-Freedom implementation, 3D CAG-like primitive to represent our components, and we can interact in this component editor and this plant editor very smoothly. It's, I would say, even better than our native CAD software to draw our 3D model. We have this hybrid architecture with a CAD 3D proxy server for model tessellation, and we have worked with the one of our guided team to enrich with a few building blocks within the 3D X-Freedom, and we were quite happy that the cylinder sensor were so enthusiastic for a lot of people here at the conference. Future work. So we have a huge work, I will say, about data modeling, and one of our goal is to make 2D and 3D consistent. What does that mean is that in our sector we're using still a lot of 2D drawings, and we have this huge 3D mockup in parallel. So we want to reconcile, to converge all this information and be able to compare a pipe circuit when it's drawn in the 2D drawings, mechanical drawings, and when it's implemented in the 3D mockup. So we will work on that, and yeah, it's something that we are still thinking and working with our colleague from Macro-Parametric. And the last point is real-time visualization of a complete power plant. So you have seen a few presentations during these 2 days. So it's very interesting to see how things are evolving. And what we want especially to have in these visualizations to be able to highlight, identify the components, and manipulate. So what we have in mind is in the future to be able to provide to our user, especially the one who are not CAD specialists, CAD experts, to be able to pick a component and provide some variations or modifications to help the main centralized database to be, the best state of the art and representing the real data, the real components that are in our program. So, it's the end. Thank you for your attention, and if you have any questions.
Thank you very much. Results and facts. Questions?
Is that first video you showed somewhere online? Will it be?
I can ask if we can put it somewhere.
Yeah, that'd be awesome. Thanks.
Or you might be able to show it at the application.
The first one.
The first one, because the audio connection sort of was.
If you want, if you are interested, I can show it again. I will check. I can send you something.
Maybe we're doing the correct. Yes.
Does the CSG operators, do you support all the Boolean, like union, intersection, and difference? Or because the only thing I saw was addition?
So the question is that are really the whole sets of operations that are very often used for CSG modeling. We have mainly worked about unions and subtraction. It's something that is original and specific at EF. We mainly work only by addition. We don't like subtraction. It was related to our, I would say, to our CAD software because, some tricks in it. And, But it was the first time that we implement subtraction. And if I'm correct, Max, we're not doing the subtraction in the X-Freedom component editor. It's delegated to the 3D proxy server who will request Open Cascade, a kernel, to make the subtraction and send it back as a desolated X3D model. We are using Open Cascade to do, in fact, a CSG operation.
Yeah, we showed us the dark plant video. Where are you storing the actual geometry? Is it in a database or is it in a file base and then trying to assemble it?
It's current work. What we have present to do is a proof of concept database, which is managed by, I would say, rules motor engine, and the user can request a set of components, the part of the power plant, and the database will answer, will roll the components related to this part or this room or this subset. And we will pack it and use in the next project some development that we are working on with the front-offer IDD team to display it, even if it's a request that involves the complete power plant. So it's our goal to be able to navigate and visualize if the user asks, okay, I want a complete power plant. So it's we have a lot to do to be able to request the database, obtain the whole data, and then merge that and work on that with X-Freedom to deliver it with insert medium to the user.
Good question back there. Yeah.
I'm just curious, how do you, it sounds like most of your source data is in CAD, so how do you load the CAD data, how are you loading the CAD data into the database and then converting from the database to X3D?
It's a very good question. So it's I will say it's one of our point of our web, so it's future work. It's how we will we use our current database from PDMS, so our CAD software, and test how our first proof of concept engineering database could be fit with this kind of data. Today, what we show you, it's only the data that we have created thanks to our complement editor and plant editor. So we haven't tested to push the PDMS current database into this new way of managing engineering information. So, but it's next step.
The next step.